everyone! We are the Chemists, and we will be showing you 3 new experiments that introduce 3 concepts in chemistry. First, Athena will be explaining the iodine clock reaction showing chemical change. We've all seen steam come out of boiling water and ice melt. And we are familiar with the colors of the leaves changing when it's fall. These are all examples of chemical reactions. But when do you know if a chemical reaction had occurred? The iodine clock reaction is an experiment that has a clear indication that a chemical reaction had occurred. I mix solution A, which consists of starch, potassium iodide, sodium acetate, and sodium thiosulfate, with solution B, which has ethanoic acid and hydrogen peroxide mixed. Both are colorless solutions. However, when they are mixed together, in a matter of seconds, the beaker turns magically black. This reaction shows one of the 4 main types of chemical reaction, which is a color change. The chain of reactions that occurred were like dominoes and eventually produced the black solution. This experiment is also irreversible, which is another indication of a chemical reaction. Other chemical reaction indications include gas production, change in temperature, and precipitation. So, where do you find chemical reactions in your everyday life? Now Lexi will be explaining the endothermic reaction of a cold pack.
Have you ever wondered why an ice pack can become so cold so quickly? Well, when you break the ice pack, it is activating the chemicals inside, which just turns it from warm to cold. What is happening is an endothermic reaction. This means that the energy in the form of heat is being absorbed from around the ice pack, which causes its surrounding to become cooler. I wanted to recreate this in the lab so that I could really see what is happening. To do so, I took my 2 chemicals that I would need, ammonium nitrate and ammonium chloride, and put them into a beaker that was filled with 80 milliliters of water. Before doing this, I took the temperature of the water without the chemicals and found it to be approximately 21 degrees. While mixing the 2 chemicals together, they were absorbing the heat from around them, which caused their temperature to drop. This was the endothermic reaction. After the experiment, I took the temperature again and found that it had dropped to about 7 degrees. Through this experiment, I can conclude that when you activate the ice pack, it is like stirring the 2 chemicals together, which causes the endothermic reaction.
Finally, Liam will be explaining the single displacement reaction of silver nitrate and copper.
Have you ever wanted to make your own silver? Or have you ever wanted to make a real-life sword just like in Minecraft? Well, today I will demonstrate a chemical experiment that will help create pure silver. To start the experiment, you need AgNO3, or silver nitrate, copper wire, a large beaker, and sandpaper. First, use sandpaper and scrape the copper wire until the bronze color is gone. The experiment won't work if you skip this step. Second, wrap the wire around your finger and make a spiral. Then put the copper wire into the beaker with at least 150 milliliters of silver nitrate. Wait for 10 minutes and you'll see silver crystals being made. After 20 minutes, you'll see even more silver crystals forming on the copper wire. You can see the silver crystals are easy to break and really fun to watch. After a day or 2, the bits of copper wire and gray silver chunks are in the bottom. The liquid itself changed its color from clear color to light blue. To take the silver out, you need to use filter paper and pour the blue liquid and silver into another empty beaker. And this is the end result. The silver that was created is shiny and sparkling. So, how did that happen? To make this answer simpler, the copper wire and silver nitrate had a chemical reaction, and instead made solid silver and liquid copper nitrate. The silver particles that were inside the silver nitrate latched itself to copper because copper is more reactive than silver, and the copper particles gradually joined the nitrate particles.